All right. Morning, guys. So the very first thing we're going to talk about today is vertical angles. And we've discussed vertical angles before, but we're going to look at them in a little more detail right now. So vertical angles are two angles whose sides form two pairs of opposite rays, which essentially means two angles that are across from each other. So if I want to look at angle ABC, which is right here, and angle DBE, make that a little smaller for you. Those two angles, which I'm talking about this area right here, this is the angle. Those two angles are across from each other. They are vertical angles. We also have another set of vertical angles in this picture, which is here, this little angle right here, and right here in orange. Do you see how they are kind of across from each other? Yes. Okay, cool. If you look right here on the windows right behind me, these two angles right here, these are vertical angles, okay? So they are across from each other, which means that they are going to be equal to each other. So if we really wanted to kind of like talk about what that means to us, we could say the measure of angle ABC, which is in pink, is equal to the measure of angle EBD, which is also in pink. We want to make sure that we have measure written out front because that is the correct way to do this. Let's go ahead and look at another slide. They've outlined the same thing here, which is what I did in the last one. They just didn't use the same colors. So we have angle ABC and angle DBE, which are across from each other, so they're vertical. And then in red on the right-hand side, we have ABE. And in blue, we have CBD, which are across from each other. So they are vertical. I personally like when I outline them in the same colors. They use two different colors to show it. Either one is okay. Vertical angles are across from each other. So what we would normally be doing is proofs. The issue with proofs is they are very difficult, and it's going to be way too hard to do them over online, and we're already a little bit behind. So we are going to actually go ahead and skip proofs. But I'm going to kind of show you down below that in a way we have gone over proofs, just not in the format that we're typically used to. So we're skipping a bunch of slides. Let me figure out where exactly we're starting at, and then we will get started. Okay, perfect. So these are your library of theorems, which a theorem is what you are proving in a proof. So I'm going to go through these and highlight the ones that we've actually gone through in class, because most of them we actually have. We just didn't call it proofs. So theorem one, adjacent complementary angles form a right angle. Well, we talked about this in class already. Next one, two angles form a linear pair supplementary. We definitely went over that in class already. Vertical angles are congruent. We went over that. All right angles are congruent. We also went over that. Perpendicular lines form congruent adjacent angles. So we talked about perpendicular lines. We also talked about adjacent angles. Two lines form congruent adjacent angles. Then their lines are perpendicular. We also talked about this because if we have two 90-degree angles like this, we know they're on perpendicular lines. We did not talk about the common segment theorem. We also did not talk about the common angle theorem. What we did talk about, though, is that angles complementary to the same angle are congruent, and angles supplementary to the same angle are congruent. So this is our list of things that we would prove if we were going to go over proofs, and we've actually gone over nearly all of them. So don't feel like you're like completely missing out, because you're not. I want to move forward in material that's going to be on the ACT. So when we talk about problem solving, we can use the postulates and the definitions that we've already gone over to problem solve. So when I think of geometry, like this is the heart and the meat of geometry. So I think that this is the most fun part of geometry, and this is kind of like why I enjoy teaching geometry. It's kind of like solving for a puzzle. So we know that ABC, which I'm going to outline right here in yellow, is 55, okay? But what we need to figure out is all of these other angles, which we can definitely do. We know that these two angles right here that I've just outlined in yellow, so this one right here and this one, they are across from each other. Therefore, we automatically know that they are equal. They are vertical angles, so they're 55 degrees right here, okay? Another thing that we know, what I'm about to outline in pink, is that this is a straight line and that this line is intersecting it. So we know that together they're going to add up to be 180 degrees. So we can take 180 minus 55. Can anybody tell me what I get with that? I believe it's 125. Perfect. So you end up with 125 degrees. So since these are on a straight line, you end up with 125 degrees. Lastly, and it doesn't ask us this question, but we're going to go ahead and do it anyway. We have this angle right here that I'm highlighting in green. And then we have this angle right here that I'm highlighting in green. These are vertical angles, therefore they're also equal. So this is 125, okay? So I'll give that a second for you to sit with that while I adjust attendance again for the people that are late. And then we'll get started again. Okay. So all we did here is use vocabulary words that we already know. So looking at another example of problem solving, this is the exact same one, but it kind of breaks it down for us again and uses different angles that I may not have used. So this is another way of looking at it. Still, you get the exact same thing. So I'll go ahead and fill this in. This angle and this angle are vertical, so it's 55, which is what they talked about right here. And then in green, they talked about how this angle and this angle are equal to 180. So we know that this is 125. And they did not talk about what I'm about to highlight in pink right here, but these two are vertical angles, so this is also 125. Okay, this is not necessarily a proof, but this is a way of looking at proofs. So looking at this again, we have another example. So the very first thing that I want to figure out is what would be vertical to this. So in the chat, go ahead and type your answer to which 1, 2, or 3 would be vertical with the 36 degrees. And we'll send it all at one time. So, oh, good. You guys are already answering. Perfect. So this is also 36, okay? If I was to look at these two angles right here, I know that they're going to equal 180 degrees. Yeah, somebody gave me the answer as well. That works too. So those two orange ones are going to equal 180. So just like they've done right here, they did, it's the same thing as doing 180 minus 36. You end up with 144. And then over here, right here is our justification for 3. We know that angle 1 and angle 3, those are vertical angles. So therefore, this one will also equal 144. Okay? So it's kind of like solving a puzzle, and you can solve it in pieces. And you might solve for something first that your partner didn't solve for, and then in a roundabout way, you'll find the answer. That is how I always know if somebody's copying somebody's homework, if they did every single thing in the exact same order as their friend, because that would pretty much not be happening. So we're going to go ahead and look at a knowledge check. This one's a little bit different. So 83, we know how to do that. 84, it wants us to determine our justification for what we did in the last one for determining angle 2. Well, we know that angle 77 right here and the angle that's 77 degrees and angle 2, those are vertical angles. So if you picked either option that had vertical in it, you would get it correct. So on this knowledge check, there are multiple answers that are correct. The reason why we don't know which one it is because we didn't completely go over proofs, but we know they're vertical angles. So if you picked either A or B, that would be correct. So 85 we know how to do. And justification for figuring out angle 3, well, 77 and 3, those are supplementary or linear. So if you picked any of these answers are correct. So solving for this one. And how did we know angle 4? Well, they are supplementary, or you could have done angle addition. So either one of these would have been an okay answer, okay? So just find a vocabulary word that makes sense with it. We've done this. This one is set up a little bit differently, so let's go ahead and look at this. We can always fill in what our vertical angles are first. So across from this X right here, across from this is this, so we know that this is X degrees. And across from this, vertical to this is this, so we know that this is 2x degrees. Sorry, the lady's trying to play her video. So if we want to talk about how to solve for this, in yellow, I'm going to highlight right here. This is a pair of supplementary angles. They're on a straight line. So setting up question 90, you could take 2x plus x equals, and they're on a straight line, 180. And then you just solve for x. Okay. Question 91, same concept. These are on a straight line. So 2x minus 5 plus 85 is going to equal 180. 92 is the same thing, but these are vertical. Vertical angles equal each other. So we have 6x plus 3 equal to 75, and then you're going to solve. 93, we have 9x minus 4 equal to 122. Same concept. You're going to solve because they're vertical. 94, these are on a straight line. So 7x plus 54 plus 42 equals 180. They're supplementary. And this one is not on your knowledge check. So I'm actually going to give you guys 20 minutes to do this. You need to have a piece of paper, and I think some of us probably need to go find a piece of paper. So you have 20 minutes to do this, and let me look up in Google Classroom exactly what this is called for you. This is called problem solving 83 to 94. Problem solving 83 to 94. So I'm going to go ahead and stick you guys in breakout rooms right now, and you're going to do problem solving 83 to 94, and I will call you back in at 1:50. If you are watching the recording of this, just go ahead and pause the video, do your knowledge check, and then fast forward to where I start going over it. So right now your breakout rooms are open. You're doing problem solving 83 to 94. So you can go ahead and go in your breakout rooms. Problem solving 83 to 94. So you're currently doing problem solving 83 to 94. So you should all be in your breakout room. If you're still in this room, you're not paying attention. So Elder, Brian, Jonathan, Lucky Boy, Julio, you should all be in your breakout rooms. Julio, you're always one of the last ones left, man. Come on. Elder, pay attention. Julio. All right, Julio, I'm putting you in a waiting room, and I'm going to mark your absent on attendance unless I get a chat from you. All right, so if you're watching the video of this, you can go ahead and pause right now, and then I will call you back in, or just take the knowledge check and then fast forward through this time and then start when I'm teaching again, okay? All right, guys, welcome back. We're gonna go ahead and go over these, and then we'll talk about another section, and then you'll be free to go. So we've got about like 30 seconds before everybody else comes back in. And then we'll get started. Like I said, we're gonna go over these and then we'll talk about another section. We will not take another knowledge check and then you'll be free to go. So got about 10-ish minutes, so just hang in there. Okay, so question 83, what is the measure of angle 2? And I'm not gonna play the video for all of these, I'll play it for about every other question. Angle 2 is vertical with 77, so let's watch her explain it.
What is the measure of angle 2? All right, well, we see that the measure of this angle here is 77 degrees, and because vertical angles are congruent, we know that the measure of angle 2 is also 77 degrees. The answer is A.
So if you knew your vocabulary word, you would have been fine there. Your justification, we know vertical angles. So if you picked A or B, either one of those are acceptable answers. Looking at question 85, we need to figure out what the measure of angle 3 is.
What's the measure of angle 3? All right, so 3 is a linear pair with 77. 77 degrees plus 103 degrees add up to 180. So the answer is B.
All right, so we talked about justification for 3. If you put A, because it said linear pair supplementary, you're correct. If you put this one, that is also correct because it also says supplementary. Either one of those options are acceptable. Looking at 87.
What is the measure of angle 4? All right, so we know that the measure of angle 4 plus 112 equals 180. So if you add these two together, you get 180. Therefore, the measure of angle 4 is 68 degrees. The answer is B.
All right. This one, justification for 4, if you put angle addition, that works, or this one because it talks about supplementary. Either one of those would be acceptable for me. Looking at 89.
What is the measure of angle 6? Well, because of vertical angle theorem, we know that these two angles are equal. Therefore, angle 6 is also 112 degrees. The answer is A.
And this one we don't have a justification of. Question 90 is the one that I already set up. So all we're gonna do is solve it. She's gonna go ahead and solve it. I went about it a little different than she did. In the end, we get the same answer. So either way that you wanna solve it is acceptable.
What is the measurement of angle alpha? All right, so this is gonna take 2 steps. Here we see that both of these are like terms. They're both x. So we know that this angle plus this angle equals 180. So we have x plus 2x equals 180. That's 3x equals 180. Therefore, x equals 60 degrees. Now that we know that this angle is 60 degrees, this one is 120 degrees. Therefore, because of vertical angle theorem, we know that this one is also 120 degrees. So the answer is C.
So I went ahead and solved for the vertical angles before we actually set the equation up. Either way that you do it is totally acceptable. Looking at question 91, these are supplementary or a linear pair, so these are going to equal 180.
Find the value of x. All right, so this angle and this angle are a linear pair. They're supplementary angles, which means when you add them together, they add up to 180. So we know that 85 plus 2x minus 5 equals 180. Then we can just solve for x. So when we combine these terms, we get 2x plus 80 equals 180. X equals 100. X equals 50. So x equals 50. B.
All right, these here are vertical angles. We know that vertical angles are equal to each other.
Find the value of x. All right, because of the vertical angle theorem, we know that 75 equals 6x plus 3 degrees. So we can just solve for x. We have 6x equals 72, x equals 12. The answer is D.
Only have a few left right here. These are also vertical angles. Vertical angles we set in an equation that are equal to each other.
Find the value of x. We know that these two angles are congruent because of the vertical angle theorem, so we can just set them equal to each other and solve for x. 9x equals 126, x equals 14. The answer is B.
All right, last one in this section.
Find the value of x. All right, so these two angles are a linear pair. They are supplementary angles. So they add together to equal 180. So we take 7x plus 54 degrees and add 42 degrees. We know that that will equal 180 degrees. So let's just solve for x. We can combine these two terms there, and that is 96 equals 180 degrees. 7x equals 84 degrees, and therefore x equals 12. The answer is A.
All right, and this one we're not going to go over. So really quickly, we're going to look at angle bisectors. So an angle bisector is a ray, a line, or a segment that divides an angle into two congruent parts. So if we look at this right here, BX is the angle bisector, and it is bisecting this angle that is outlined in pink, which means the area that I'm outlining in orange, these two angles right here, are going to be equal because anything is bisected, it is going to be cut in half. So continuing on to look at this, the same thing, we want to determine these angle values. Well, we know that BD is bisecting this, and so that tells us that if this angle right here is 52 degrees, this one right here also has to be 52 degrees, okay? It also wants ABC. I'll do that one in pink, sorry, ABC, which is the entire big one. And through the angle addition postulate, we know that we can take 52 plus 52, and together that's going to equal 104 degrees. Okay. So typically right now you would take a knowledge check, but I want to take a little more time going over this next class. So I will stay in class right now and answer any questions that you may have. But if you don't have any questions, you are free to go.
Bye.
Bye.